we're trying to power this simulation. It's like a giant what-if machine. Now you can play out all of the various paths, almost like a giant tree of potential interaction. So it's like you've got this little multiverse explorer where you're like, oh, what if I do this? What if I do this? And you can kind of see that happen, which is critical for like the AI to suggest what's the best next action. Our mission as a company is to create huge amounts of value for our customers. That's sort of been like the North Star. A lot of the customers we work with, especially if you think about consumer goods, they're multi-product and multi-country, right? And so you actually have some inbuilt forces that will pull you towards creating an abstraction that's at least at a global level.
Hi, I'm Brett Gibson, and welcome to HiBit, a new podcast where we do deep dives on the art of problem solving with engineers and technical experts from our community of early stage startups. In today's episode, we're sitting down with Pratap Ranade, CEO of Arena AI. Pratap is a quantum physicist who studied machine learning, spent some time at McKinsey, and went on to sell a data company he founded to Palantir. He's now the CEO of Arena AI, a company that uses AI to translate data into a real-time simulation platform, offering insights into sales, pricing, promotion, and marketing strategies. The details of engineering problems fascinate me, but I'm just as interested in how the best engineers I know think, how they zoom in on which details matter the most, and then use that focus to navigate to elegant solutions. Join me on this journey as we discuss thorny engineering problems with my guests and get into the weeds about how they solve them. Hey Pratap, thanks a lot for joining me today.
Hey Brett, yeah, it's great to be here.
Maybe you can start off telling us what Arena does.
Yeah, so high-level Arena is the central brain for a large enterprise. We've entered the era of large foundation models, and we primarily work in consumer goods, so it's CPG companies as a central brain that really understands customer behavior. So you can think about like a large language model. It's like a behavior model that's understanding customer behavior. Some of our customers are Anheuser-Busch, InBev, AMD, the microchip company, Bausch & Lomb, the list goes on. And then more recently, we've also started working in the advanced manufacturing industry, again, to understand the behavior of complex physical systems.
Oh, that's awesome. I don't know that it would have been intuitive to me up front that those two are part of the same system, but it's very interesting that they are.
Yeah, same technology, but two different products.
Okay, so what is difficult about what you're building?
Many things are difficult. So I would say they probably fall into three buckets. I think the first one is when you're working with a really large, complex global organization, it's seldom enough to just have something you can just install as a widget and say, great, my supply chain is fixed, I install this software. It's like never like that. And so the motion of ensuring that your software is actually driving huge amounts of business value is somewhat hands-on at the beginning. And so that requires like plugging into their systems. It requires actually even sometimes working with users to make sure that last mile of like, if we're ultimately injecting intelligence into a workflow to power it like autonomously or semi-autonomously, it requires like working pretty hands-on and pretty closely with the customers, which is really fun for us. And then it's up and running. So I think that's one component, which is really like being very close with your users and with this, the systems right at the beginning. The second one has been half the battle is making sure the model works correctly and giving you like good outputs. But then the other half of the battle is actually making sure those outputs are understandable enough to be accepted and used by a person. And so they're actually different problems because that's sometimes you have the right recommendation, if you will, but the human doesn't believe it. And sometimes the human doesn't believe it because it's a wrong recommendation. And so that's tricky. Like, where do you take human feedback and where do you actually need to do a better job explaining why the human should listen to the machine? It's like kind of a symbiosis over there, but getting that right is a delicate balance. And then the third one, which I think we might spend more time talking about, is how do you actually teach the machine to structure the world? And what kinds of abstractions do you put in it? And how do you know that you're not imposing your own sort of preconceptions into that, and where do you let the machine sort of come up with abstractions itself? And I think this is becoming, as the models become more and more capable, is becoming more of a topic of debate.
It's really interesting, especially given the breadth of domains that you're working with. The kind of models you're training, it takes time and effort to train them. And so part of the problem is that you need to anticipate in the architecture what features people are going to care about. and how to do that in an abstract way across domains.
Yeah. So, I'll pick the consumer goods example as a good one. So the very first time we did it, we sort of were focused on specific features for the specific problem that we were solving, but obviously that wasn't generalizable. And then we stepped back and we realized across consumer goods, you have sort of a few fundamental entities, right? You have this physical product that you're selling. Maybe it's a Budweiser, maybe it's toothpaste, right? It could even be a service, right? But there's fundamentally some product that you're selling to a customer. And that customer in many consumer goods contexts is a store. It's like a small store, or it's a large store, or it's a supermarket, or it's a restaurant. But in some cases, it's an actual end consumer, right? So you have the customer is making contact with the product. And the name of the game in consumer goods is like, well, I want you to buy that product. And it's in a sea of competitive products. What can I do in my power to persuade you to find the right product for you and buy that product? And there's some elements you control and some elements you don't. So things that you don't control, for example, is it a hot day? Is it the Super Bowl, right? There's a set of context that's happening that's out of your control. And then there's a set of actions that are in your control. Like, okay, great. Like, am I going to spend on marketing for this product versus this product? Am I going to put this product in a specific location in the store or a different location? Am I going to run a promotion, run a discount? So, if I'm going to do those things, should I make sure I've got more inventory so it doesn't run out of stock and you have an empty shelf? So you've got a ton of these things where in our world, that's kind of a fundamental layer. But then if you move across categories, it gets more interesting. You're like, well, what's common between a toothpaste and a t-shirt and a beer? And how tight or how loose are you in terms of that sort of metadata that you use to characterize the product? Like, you probably want to look at the picture of the product. Maybe red products with red labels sell better on Valentine's Day. Like, who knows? But if you don't have that data feeding into the system, then that's not part of your sort of like embedding space that the machine builds for the product. And then that's not a learnable thing, right? So the idea right now is, how do we put as much into the space as possible so those relationships, should they exist, are learnable?
Yeah, I feel like there's this general problem in inventing taxonomies or ontologies generally. It's always arguable what should and should not be in it as a primitive. So how did you start? Like at the very beginning, like the two obvious ways are try to do it top down, try to just like a priori come up with everything. The other is, find a few examples and abstract it out. And like from day zero, what was on your mind? What was your first attempt at tackling the problem?
My co-founder and I have a very healthy kind of yin and yang, where he's taught me a lot about like speed and practicality. And so we definitely took that approach and we said, let's start with concrete examples. Let's not over abstract the problem. Let's get the thing to work and let's deliver like good recommendations that add value. And as we took on more problems, sort of then some of our shared thinking became, okay, what's the right level, the minimum right level of abstraction, right? So the idea is you don't want to, the risk with over abstracting is obvious. Like, we white build like beautiful ivory tower model that serves no utility. And fundamentally, like, our mission as a company is to create huge amounts of value for our customers. And so if you think about that, that's sort of been like a little bit the North Star. What's been really interesting is a lot of the customers we work with, especially if you think about consumer goods, they're multi-product and multi-country, right? And so you actually have some inbuilt forces that will pull you towards creating an abstraction that's at least at a global level. And, as these companies grow and acquire other companies or new brands, their product lines expand too. So you'll have, many food and beverage companies are selling various types of food, various types of beverage. They're probably even getting outside of that. And they're selling them in markets as different as Brazil or Thailand or the United Kingdom, right? So you have to sort of deal with that. And I think what's been really exciting is as you can put more of these countries and more of these systems into the same model, imagine for a second that the model was a baby economist. And it's actually now empirically getting to sample data, but from real-time transactions all over the world. I mean, in a way, you've got like the ultimate experimental economist.
Yeah. You're starting from the specific, you're starting from the lens of let's drive customer value first and, work on the platform second, more or less. And were there points where you're like, all right, whoops, we have to circle back pretty far because there's some concept we didn't anticipate?
Yeah, I think there definitely have been cases like that where, for example, product imagery took us a lot more time to take into account, right? Because we're like, oh, look, if we know the SKU, like we know if it's in a carton or a plastic crate or, if it's a bottle or a can, there's a lot of metadata that you can go and you can use. There's a lot of text metadata and, people have done a good job about tagging and cataloging things. And, we've had like various databases and data lakes for some time now that have encouraged people to label things and put in more of that metadata. And so, it's always harder to include a new modality of data. But now with the advent of like, more widely available large language models with image capability as well, our ability to ingest larger amounts of metadata and code it has increased, right? And so you start asking yourself the question of like, what else should we be including here? Like ultimately you think about like consumer products, like one thing we don't have the ability to do yet is taste. So you're going to write down like what people think it tastes like. But at some point as sensors evolve, like it probably makes sense to take like chemical profiles of these things into account. On the flip side of this is just from the product side. If you think about it from what speaks to the consumer interaction, of course, it's the purchase signal is the most important, which is I bought it or I didn't buy it. But there's a whole bunch of other things that happen before that, which if you're in a physical store, it's like, oh, what are you looking at? Maybe if you have store cameras, right? But if you're online, then it's your click stream. And so there's a ton of signal actually in some of these sources. And if you can ingest the right modalities, you can formulate a pretty good picture of like, kind of like almost a little bit predictively, and which for us is important because we're trying to power this simulation. It's like a giant what if machine. If I do this, how are you going to interact? But not just like, will you buy or not, which was kind of old supervised learning, but now you can play out all of the various paths, almost like a giant tree of potential interaction. So it's like you've got this little multiverse explorer, if you will, where you're like, oh, what if I do this? What if I do this? Yeah. And you could kind of see that happen, which is critical for like the AI to suggest what's the best next action.
Yeah. And it sounds like almost the shape of it is you get good at the iteration speed of the entire system of adding things in, and then you just have your customers lead the way in terms of pulling you into the new concepts you need to be thinking about. And it's a little bit reactive, but the art is the efficiency of the reaction.
Yeah, it's reactive, and then every so often we have to purposefully swing the pendulum back and say, okay, wait a minute, like what's possible now? And then sometimes we then take that to our customer. We're like, hey, did you know we could do this? And then they'll say, oh, okay, wow, that's interesting. And then you'll probably wind up in a different place. But there is this sort of like healthy tension. You start sort of from their problem, you understand what your capabilities can bring, and then you go back, but now you're speaking their language. And so then that actually really helps.
And so, in the arc of the company, you were doing a lot of CPG-based models, or for CPG companies rather, and then did you go look for a domain that was wildly different, or were you actually like, let's exercise the breadth of this thing, or was it like, let's add this domain on, we can kind of do a parallel path and merge it? Like what did that look like when you started?
Yeah, so it's definitely a bit of an unconventional approach. We definitely broke from the textbook here. We're like, well, we should just stay in CPG would be like one answer. So I mean, if you look at like what's happening with language models, we're adding tremendous amount of value in the domain of knowledge workers, where most of your work is like in text or in Excel. But if you think about these companies where so much signal is in the physical world, that's like consumer goods, where you have sales reps on motorbikes and like bodegas in like the middle of various countries. And then you also have advanced manufacturing. And so that was the other sort of like large physical industry that we were very excited about. Also complex system to simulate, but very different system, not a human system, also a stochastic system where we thought there was a pattern. And, personally, I've always been excited about that, about like bleeding edge physical technology. And so we said, let's give it a shot. And it worked incredibly well. And so, we started that about a year ago, but now our advanced manufacturing group is scaling quite quickly.
Awesome. Could you tell us a little bit about your background and how you came to this problem and idea?
Yeah. So, I started out as a physicist. So I studied physics in undergrad and then continued on to grad school. I didn't finish my PhD. I wound up spending 4.5 years in it though. Then when I realized I just didn't want to be a professor, I switched gears. I went to consulting, which was a total switch, but I'd never even taken an econ class. So the idea was I probably need to get some basic business education somewhere. Physics is where I first encountered a lot of like the math. I used to program in high school, and then I took a ton of machine learning in grad school. And that sort of created at least like a little bit of a theoretic foundation, and was really excited about, machine learning and the promise it had. And then later on starting my first company out on the West Coast, and we went through Y Combinator, and that's where I met Gary, and then we wound up selling it to Palantir. And so across Palantir and McKinsey, I saw a lot of these Fortune 500 class enterprise problems, realize how important these companies are in terms of like so much of our experience in the world. It's like powered by a lot of these companies, like the food we eat, the power we use, like the phone plans we're on. And so we were looking for what's our fulcrum to have maximal impact. And it feels like if you could actually move the needle on those companies, you could really like create just a better situation for consumers and for everybody. Personally, we wanted to work on the frontier of AI. We started Arena in 2019. We had seen what was happening in 17 and 18 with transformers and reinforcement learning. We're like, we don't exactly know what this looks like. This is way before LLMs, but we're like, this is probably the future. Let's get our hands dirty. Let's get involved with like complex problems and bleeding edge research. And a lot of the inspiration was something like Bell Labs or Lockheed Martin Skunk Works. We're like, look, it's not clear that you're going to make a stealth fighter yet, but something's going on here with these new composite materials and the needs that we have. And so for us, it was like something's going on here with AI, and the enterprise is not only like a great fulcrum to have impact, but they've got like large data. And so there's a huge opportunity to sort of pioneer this. And we were lucky enough to find our early customers who, they took that bet. They were willing to like take a leap. And I think we're super grateful because that's uncommon, right? For a large enterprise, some executive of a large enterprise to take a risk. And so, very much like, Arena exists because those people took a bet on us.
You kind of this insight that machine learning is doing wild and amazing things, but there's these new architectures that generalize in a way that takes us a lot further. What strikes me about your early customers, you were way ahead of the curve, right? You started applying these techniques before ChatGPT comes out and before enterprises widely have this vague like notion of we need an AI strategy. Have you noticed a difference in the conversations over the last years or over the course of Arena?
I think what was really awesome about ChatGPT and what OpenAI did is I think it massively educated the market. Like the terms foundation models, they became terms, right? We were like, oh, wow, there's a way to describe this now. People started believing in the ability for these large machine learning models to learn more generalized patterns. Pre-trained models became well-understood concepts. It had a huge effect there. And I think it also helped clarify, because earlier, even in our sales process, it was like, oh, how's this different from like, the regressions my data science team runs? And it was all bucketed under this general clump of advanced analytics, right? And so it helped, I think, a lot of customers realize this is different. And so that was a super positive. And I think where we are today is like for the last year, the complexity has been explaining that actually the powerhouse here is the transformer model and a lot of these like underlying capabilities. AI is much more than LLMs, right? And I think that's probably the number one explanation that we have to do when we're in our sales meetings is like, LLMs are amazing and you should totally use them. There's so many amazing things I can say about them. However, all of your problems aren't probably going to get solved by throwing it at an LLM. And you have other modalities of data and you have really new technology capabilities with transformers, especially when you're operating things like time series data, right? Which is a big chunk of our work. And I think for us, we've still found that the best way is seeing is believing. So deploying with a customer in their setup, then they see the results. They see what that means in terms of changes to workflows and like real results on the ground. And it makes that link a lot more clear than it's more than document drafting, right? It's a lot more capable.
Yeah, totally. I mean, because it's obviously, words are everywhere. And so large language models will have their place, but most of the data that is running a lot of decision making isn't in time series and numeric in nature.
Yeah.
Are you getting in the door in a more general, like, we want to talk about AI and then having to do a lot of education right now?
Yeah, I think, what's been nice is more and more of the education is getting handled as people are coming up the curve. What's been really special about coming into customers now is there's an openness to it. And, when we can speak about specific use cases, which is, I think, one of the things that's really differentiated our company, which is deploying real use cases at production scale with the Fortune 500. Again, because we started so long ago. We started in 2019, like before this, we've been chipping away at that. And so that's actually been what has been very powerful with our customers. They're like, oh, okay, wow, I get it. You're like solving like a huge problem with physical testing of complex systems and it works. And I can see how it will work in my environment. Or you solved a huge problem with like precision tasking my Salesforce or running promotions. And it's like, those are things that they can understand. And then what's interesting is then you get to have the fun conversation, which is, oh, wow, how is that problem solved? And we're like, well, doesn't it make sense that you could have a giant mind that instead of generating an essay, generates a simulation of how your customer is going to behave? And they're like, oh, yeah. And then it gets really exciting because usually in most of our cases, after that first sort of use case is deployed, our customers start coming to us with, well, here's all these other 6 things I want to do with Arena. And so that's where we are now. And it's a really exciting time.
So what should we look forward to from Arena? What's next?
Yeah, so we've got a couple of big releases coming up. So we'll be announcing something soon about our advanced manufacturing work, which we're super excited about. I won't spoil that, but it's working with some very, very cutting edge technology that's core to what everyone in the world is doing. So that announcement is coming up. Stay tuned. And then we have another new product built off of our customer behavior simulator that we will be coming out with. It's in an alpha, it's in a closed alpha. People are testing it. I think that's going to be really exciting because both of those are going to be easier to access, easier to understand. And so hopefully it'll help demystify some of the automatic mystique that comes when you're dealing with like large, complex Fortune 500 problems that are not the most obvious things when we think about. But yeah, those two big ones are coming up.
That's really exciting. All right, this has really been a lot of fun. You're at the cutting edge of what's going on with enterprises and AI, so it's always very educational.
Thanks so much, Brett. Thanks for having me. It was fun to be here.
That's it for this episode with Pratap Ranade, CEO of Arena AI. HighBit is produced by Initialized Capital. Our showrunner is Candy Chang. Our videographer and editor is Kevin Heinz. And I'm Brett Gibson. Thanks for listening.